Hi, complex numbers, Euler's formula. Using the Euler's formula, which is given by e to the I theta equal to cos theta plus I sin theta, show that sin theta equal to e to the I theta minus e to the minus I theta divided by 2i, where I is a complex number. Prove the identity sin theta times sin phi equal to half cos theta minus phi minus cos theta plus phi. So to begin with, we'll try to write the Euler's formula, which is given by e to the I theta is equal to cos theta plus I sin theta. This is the Euler's formula. And now what we do is we substitute theta with negative theta. So then what you get here is e to the I negative theta. Instead of theta you put negative theta equal to cos negative theta plus I sin negative theta. So you need to know why we do this one, because we need to get another term called e to the negative I theta. E to the I theta is already known, so we need to get this one. So what we do here is we substitute theta with negative theta. So you got here e to the I times negative theta. So it's basically e to the negative I theta. And now we have cos negative theta, which will, if you look at your quadrants, four quadrants, so this here all the uh, trigonometric functions are positive, sine positive, tan positive, cos positive. So what we have is an angle theta of cos. So this is theta here, and if you take negative cos theta, it lies in the fourth quadrant. It is cos is positive. So therefore cos negative theta is also just cos theta is positive. Cos negative theta equal to positive value. Therefore we write cos negative theta equal to cos theta. Here sin negative theta will become negative sin theta, because it will be negative here, because negative theta is negative, because only cos is positive, sin is positive in the second quadrant. So therefore this will become negative I sin theta. So now we have two expressions, one here and two here. So what we do next is we need to remove cos term, because we need only sine term here. It's a sine term here. So to get rid of cos term, what do you do? Here cos theta, here cos theta. So we take away equation 1 from equation 2 from equation 1, or either way. So we'll see 1 minus 2 will give us e to the I theta minus e to the negative I theta at the left hand side, and equal to cos theta terms will get cancelled off, and I sin theta, and this negative, because we are subtracting this second equation, this negative and negative become positive, get positive I sin theta. So get 2 I sin theta here, therefore it's equal to 2 I sin theta. Now what we need is to get sin theta into the left hand side and bring 2i down here. So basically we cross multiply, therefore sin theta is equal to e to the I theta minus e to the minus I theta divided by 2i. The 2i goes down here when you cross multiply, and sin theta will remain. So then you swap the sides. So sin theta equal to e to the I theta minus e to the minus I divided by 2i. That is what you have to prove in the first part of this question. And the second part of the question is to prove the identity. So we are given this one, sin theta is known. We need to find out sin theta times sin phi equal to what is so we can prove this one. So what we do here is get your sine theta back again. That means sine theta is known as sine theta is equal to e to the I theta minus e to the minus I theta divide by 2i, and we can write sine phi. Instead of theta we put 5, then you get e to the I phi minus e to the minus I phi divide by 2i. Now we have two terms, sine theta and sine phi, so multiply these two, sine theta times sine phi, so you multiply these terms equal to e to the I theta minus e to the minus I theta divide by 2i times e to the I phi minus e to the minus I phi divide by 2i. Here in the denominator you can see 2i times 2i, 2i times 2i, which is equal to 4 times I squared. But I squared is -1 because we know I is equal to square root of -1. So if you multiply I times I, so basically the square root will go off and it will become -1. So therefore here this will become 4 times -1, or it's equal to -4. This is our denominator in this question. So we put the denominator equal to so we have brackets, we'll put the bracket here, and we have a large line here, and then -4 here. So 2i times 2i is -4, and now we multiply this one, e to the I theta times e to the I phi minus e to the minus I phi minus, and this multiply with this one, and then multiply with e to the minus I theta minus I theta times e to the I phi minus e to the minus I phi is the numerator. Now we have to expand this one, is I here, and then expand here, e to the I. So you need to make sure that when you multiply two exponents, e to the a times e to the b, what do you get? It will become e to the a plus b. If you multiply e to the a times e to the negative b, what do you get? E to the a negative b. So this is the exponent, so you got to be careful here. Not a times b, it's a plus b and a minus b. So similarly we have I theta and I phi, so it's I common term, you can take I out, so it's basically theta times phi means theta plus phi is e to the theta times e to the phi is the theta plus phi minus e to the, there's a negative sign, you take the negative sign out, and I, so either you can keep it in here. So if you keep it in, that means e to the theta times I phi. So if you put positive here, what you get is theta negative phi. And next one, e to the negative I theta times e to the I phi is equal to e to the negative I theta minus phi. You take the negative out, so that's why we have a negative sign here. Similarly, we took a negative, we didn't take the negative out here, so we have I theta negative phi, and when you take negative out here, theta negative phi, and then negative positive e to the negative I plus times negative here. So basically there's a negative time there, so negative I take out. It's not just add theta negative I theta to the negative I phi, so that will be negative I common, then it will be theta plus phi. So make sure that you're not multiplying here, this is basically adding, so that's why this negative will not cancel off here. So that's the denominator, that's the numerator, and then the denominator is negative phi. So now we need to find out what is the common terms here. We have theta plus phi here and theta plus phi here, and we have theta minus 5 and theta minus 5. So okay, this is what we got just now. What we're trying to do now is to collect the equal terms. In this case, theta plus phi and theta plus phi are similar terms, and the other one is theta minus phi and theta minus phi. So what you do here is you take e to the I theta minus phi, first one, plus this will become plus because this negative will make this one positive and this one positive there. So e to the I negative I theta minus phi divide by, we'll give 1 2 here, and then take another 2 outside here because there is 4 underneath, so this 4 will come positive when you multiply with negative sign here. And then you have another term, this negative will make this term negative, so put negative here, and then e to the I theta plus phi minus actually this negative and this negative, there'll be 2 negative signs, so you take the negative out, then this becomes positive, e to the minus I theta plus phi divide by 2. So please careful about these negative signs here. So what I did first was this one, negative negative positive, so that's why we got a positive term here, e to the I theta minus phi minus plus e to the minus I theta minus phi, and then this negative sign will make this one negative. I put that negative here, e to the I theta plus phi positive, plus this plus became negative when you multiply here with this negative sign, but now we have a negative sign here, so this will be positive here, e to the negative I theta plus phi. So when you look at this one, this is actually cos term, cos theta minus phi, and this one is called cos theta plus phi. So that's what we need to prove. So that is negative of that, and that's a half here, half times cos theta minus phi minus cos theta plus phi. That's the answer to this question, the second part of the question. So we did this one earlier, and now we did this one.